Now let us discuss about the wave nature of electromagnetic radiation. We all know that light is a form of energy, right? Light is a form of energy. It is also called electromagnetic radiation. Why is it called electromagnetic radiation? Or you can also say electromagnetic wave. But why? Because, you know, electromagnetic wave can be generated by the oscillation of a charged body in a magnetic field, right? You know, in this you got a charged body which is electric in nature, and say that is oscillated in a magnetic field. So there is electric thing and there is a magnetic thing, right? So you got a charged body. When oscillated in a magnetic field, you get electromagnetic wave. You can also get the electromagnetic wave by the oscillations of a magnet in electric field. If you look at this, you got magnetic field, and of course there is some electric thing also. So because it has both the electric and magnetic things, it is known as electromagnetic field. Okay. You know, the electric and magnetic field components are generated mutually perpendicular to each other. Of course, perpendicular to the direction of the propagation of the wave. Let me show you all the things one by one. Let this be Z axis, right? Then let this be your Y axis. Then this be your X axis. Okay. You know, they are in fact perpendicular to each other. Of course. You know, this X is the direction of the propagation of the wave. I mean, this is the area in which, I mean, it is the direction in which the wave is propagating, wave is moving. Now, let me also show you the electric and magnetic fields perpendicular to this x or the direction of the propagation of the wave. Let me first consider okay. Let us consider this. Now, this is the electric field component. Perpendicular to the direction of the propagation of wave. Then is that okay? Now, this is, of course, the magnetic field component. Right. So you got the magnetic field component and of course the electric field component, which are again perpendicular to each other, right? See them, they are perpendicular. You have to imagine a three-dimensional one. See, this and this are perpendicular to each other. Even they are perpendicular to this, I mean the direction of the propagation of the wave. Hope that is clear. Now, you know, every wave will have some characteristics. Coming to the characteristics of the wave. See, a wave is characterized by some special features like wavelength, frequency, time period, wave number, then amplitude. Okay, of course, it will also have some speed. Let me give you all of them one by one. Come on, the first one is wavelength. You know, wavelength is simply let me just okay. You know, it is in fact the distance between two successive similar points which are in the same phase. Okay. Then what are the two successive similar points? You know, this is called crest. and this is called a trough. Even this also is a crest, right? Distance between two successive similar points. Take a point here and a point here. This, of course, is your wavelength, represented by lambda. Not just that, if you want, you can start here, end up here. Even this also is your wavelength. In simple terms, length of a wave. What do you mean by a wave? A wave is nothing but one crest and one trough. Check out. You know, in fact, if you observe, this is one full crest and this is one full trough. But see, because you have started here, you have taken it, this as half the crest and the remaining half crest is considered over here. Of course, this is the full trough, right? So a wave is nothing but one crest and one trough. So the length of a wave, of course, is wavelength. Let me tell you that it is the distance between two successive similar points which are in the same phase. You know the two successive similar points may be crests or troughs. You can also define it as the distance between two successive crests or troughs. Right. Now, it is represented by this symbol called lambda. Okay. Now let us see the units. Units of wavelength. You know, wavelength, of course, will have the units of length, right? You can give it in angstrom. Angstrom units. You know, 1 angstrom is equal to 10 power minus 8 centimeters or 10 power minus 10 meters. You can also give that in a nanometer. Nanometer or even millimicron, both are same. You can give it in angstroms, you can give it in nanometer or millimicron, both are same. Okay, this can be given as 10 power minus 7 or 10 power minus 7 centimeter or 10 power minus 9 meter. Sometimes given in picometers also. You know, 1 picometer, pico. Meter can be given as 10 power minus 10 centimeters or minus 12 meters. You can simply give it in microns. You know, 1 micron, this is micron. 1 micron is 10 power minus 4 centimeters or minus 6 meters. You know, millimicron is nothing but 10 power minus 3 is milli. I mean, 10 power minus 3 meters is 1 millimeter. Micron is 10 power minus 6. That is what you got as 10 power minus 9. Isn't it? So, nanometer or millimicron is nothing but 10 power minus 9 meters. So this way you can use different units. Of course, you'll get all of them in solving the problem. This is all about wavelength. Now coming to the velocity of wave. The second characteristic of a wave. You know, all types of electromagnetic radiations. I'll give you the list of all the electromagnetic radiation. All electromagnetic radiation travel with the velocity of light. Even in vacuum also, the travel with the velocity of light. Then what is the velocity of light? You know, velocity of light, we know that it is represented by c. The velocity of light can be given as 3 into 10 power 8 meter per second. This is the SI unit, right? Then you can also give it in CGS unit. 3 into 10 power 10 centimeter per second, because 1 meter is equal to 10 power 2 centimeter. I mean 100 centimeters. Okay, so this one multiplied by 10 power 2 gives you 3 into 10 power 10 centimeter per second. Okay. Next. Coming to the frequency of a wave. Simple. Frequency, the number of times. Frequency, the number of waves. Number of waves that pass through a particular point. A point under consideration in unit time. How many waves pass through a particular point in, say, 1 second? Number of waves passing through a particular point in 1 second. The number of waves can also be called, I mean, a wave is called a cycle. A crest and a trough is called a cycle. So you can also say that the number of waves is nothing but the number of cycles. Okay, so the number of cycles per second, that is of course the unit. Cycle per second. Of course, hertz. Okay, The unit hertz is given after its discoverer, Heinrich Hertz. You can say cycle per second or hertz. These are the units. Now, let us go for a time period. You know, it is simply the reciprocal of frequency. Okay, let me show you that frequency is represented by this particular symbol called nu. It's not mu, it's nu, remember. Time period, of course, is represented by t. So now t can be given as 1 by nu. You can also define it as the time taken for one complete cycle to pass through a particular point. Okay. The time taken for one complete cycle to pass through a particular point under consideration, right? Number of cycles or number of waves that pass through a particular point is frequency. Time taken for one complete cycle to pass through a particular point is the time period. Now we know that it is cycle per second in case of frequency. The units of frequency are per second. So here we can give the units of time period as seconds. Because it is 1 by nu, right? Units for nu are 1 by per second. Now this per second when goes into numerator, it becomes second, right? So the units of time period are seconds. Next. Let us see what wave number is. You know, wave number is represented by nu bar. The name itself indicates that it is the number of waves present in unit length that are spread in 1 centimeter or 1 meter length. Okay, simple. You can also define it as the reciprocal of wavelength. So now this can be given as nu bar is equal to 1 by lambda. We know that the units of lambda are centimeter or meter. Then the units of nu bar will be per centimeter or per meter. Per centimeter in CGS system, per meter in SI system. Okay. This is about wave number. Right. Next. Coming to the last one, that is amplitude of a wave. Okay. So it is very simple. It can be given as it can be given as the height of the crest or a depth of a trough of a wave. Simple. You know that this is crest and this is trough, right? It can be simply given as height of a crest or depth of a trough of a wave. You can also say that it is the maximum displacement of a wave from its origin. This is the origin point. The maximum displacement is this, of course. Onto the other side, it is this. So the maximum displacement of a wave from its origin. I mean, from where it has started. Okay. It is nothing but the distance, right? So you can give that the units of amplitude are simple. Distance is measured in centimeter or meter. Right. Of course, the angstroms, even the nanometers, millimicrons, picometers, you got several varieties, but the basic ones are centimeter in CGS system and meter in SI system. Okay. So these are the 6 characteristics of a wave. Now let me give you some interesting things. Or let me say important formulae. Frequency of a wave is inversely proportional to its wavelength. Right? This is frequency. And this, of course, is wavelength. And when I write something in this way, remember it is called inversely proportional. If something is looked at in this manner, we call it, or we say that they are directly proportional. Once again, directly proportional, and this is inversely proportional. But remember, you should not say that this is frequency is inversely proportional to 1 by lambda. No, don't say that. If you say so, it will become this. And finally, it becomes this, which is wrong. So say that they are inversely proportional to each other. Frequency and wavelength are inversely proportional. Don't say frequency is inversely proportional to 1 by lambda. Say frequency is directly proportional to 1 by lambda. That is okay. Because this is directly proportional to this. Inversely proportional to this. Hope this is clear. Now, coming to the next step. As I said, whenever you got a proportionality that has to be removed using a constant. Now the constant that I'm going to use is a c, nothing but the velocity of light. So this is a very important relation. Nu is equal to c by lambda. Now coming to the next one. You know, energy of the radiation is directly proportional to its frequency. Energy and the frequency are directly proportional to each other. Now again, let us remove this proportionality by writing a constant. Now this constant, of course, is very important. Even the formula is also very important. E is equal to h nu. Let me write one more step before telling you what h is. E is equal to, let us keep h as it is, but we know that nu is equal to c by lambda, right? Let me substitute that here. So E can be written as h into c by lambda, simply hc by lambda. Then what is h? You know, this h is called Planck's constant. Right? Coming to the values of this Planck's constant, very important, you have to remember 6.625 into 10 power minus 27 erg into second. It's not per second, remember, erg into second. This, of course, in CGS system, because erg is the unit of energy in what? CGS system. It can also be written in joules. 6.625 into 10 power minus 34 joule into second. This, of course, in SI system. From this, I think it is very clear that 1 joule is equal to 10 power 7 erg. So this thing multiplied by 10 power 7 will give you this one. Right? That's it. So this is another interesting relation. Now, let me go for one more. See, I told you that nu bar is equal to 1 by lambda. I mean, wave number is the reciprocal of wavelength. Now, can we write this lambda? Taking nu is equal to c by lambda into consideration. Can I write a lambda as c by nu? Isn't it? Lambda goes here, nu comes here. Right? Since nu is equal to c by lambda, we can simply write a lambda as equal to c by nu. So therefore, it can be written as a nu bar is equal to nu by c. Even this also is an important relation. Of course, the basic one is also very important. Now let us go for one more. We know that E is equal to h into c by lambda. Now let me write this as hc into 1 by lambda for convenience. Now we know that this 1 by lambda is nothing but nu bar. Now let us modify this as hc nu bar. Even this also is a very important relation. You can solve hundreds of problems on all these relations. Okay. So this is all about the characteristics of wave and the important formulae used. Now let me also give you what electromagnetic spectrum is. I mean the different types of electromagnetic radiation. Now this is something in which different types of electromagnetic radiations are arranged in the increasing or decreasing order of their wavelengths or frequency. Of course, our energies are wave numbers because these are all interrelated, right? Now, let me give you the list of different types of radiation. Come on. Cosmic rays, gamma rays. This is gamma. Then, of course, X-rays. Cosmic rays, gamma rays, X-rays. Then we have UV. And then, of course, visible. So within visible, we have what? Violet, indigo, blue, green, yellow, orange, and red. VGR. Yes. Okay. Then, of course, the microwaves. Then, of course, the TV waves. And finally, the radio waves. MTR. That is how you can remember. MTR. Now, coming to this, you know, from here to here, let us see what happens. From cosmic rays to gamma rays, you know, wavelength increases. Check out the arrow mark. From cosmic to gamma. If you want, I'll write. From cosmic rays to, of course, the final radio wave. Wavelength increase. You know, when wavelength increases, frequency decreases. Because we know that the frequency and the wavelength are inversely proportional. Now, see, frequency and wavelength are inversely proportional. So when wavelength increases, frequency decreases. Now coming to energy, E and nu, energy and frequency are directly proportional. So energy also decreases, right? If you want, I'll show. In case of these two, we know that nu and lambda are inversely proportional. In case of these two, we know that these two are directly proportional. And one more. What is that? Wave number. Even wave number also decreases. Because we know that E is equal to HC nu bar, from which it can be written as E and nu bar are directly proportional. R from the relation nu bar is equal to nu by C, even nu bar and nu are directly proportional to each other. This is all very interesting. You have to analyze the things. Very much important for solving multi-answer type questions. So remember, you got cosmic rays, gamma rays and X-rays. One second, I think we have actually missed one more. Here it is, of course, IR. Right, we have to take these three in the next step. UV, visible and IR. After that, microwaves, TV waves and radio waves. Yes, I think we missed IR in the middle. UV, visible and IR, then after that micro, TV and radio. This is how you can remember the thing. Okay. Even in VGR also, if suppose a question is asked, you must be in a position to answer. Okay. So this is all about the electromagnetic spectrum. From violet to red, wavelength increases, wave number decreases, frequency decreases, energy also decreases. Okay. So this is about electromagnetic